Hey, welcome back to my channel. For this video, I'm going to continue working on my dice rolling app. Now, this last Friday, I had a live stream where I was working on creating an animated roll mechanic, because currently in the app, all I have is a physics-based roll mechanic, and I thought it would be a good idea to give the user the option of doing either a physics-based roll or an animated roll. Now, in the live stream, I thought I'd start with the most common and easiest dice, which is the D6, and I was creating all the different animations that I would need in order to create an animated roll mechanic, but I was running into a bit of a problem with the animations. So let's talk about that, and I'll show you how I resolved it. Now here's some actual footage from the live stream on Friday, and you'll notice that as the dice is trying to roll to a specific number, the animation itself is not very smooth, and a lot of times you'll see it snapping into place. Or sometimes it'll even be rotating to the number, but then snapped the other way around. Now there's a couple different terms or principles that explain why this happens, and they are Gimbal Lock and Quaternion flipping or Quaternion ambiguity. Now I already had a pretty good understanding of these principles, but I wasn't sure what they were called, nor did I have a very good definition or way to explain it. And so I ended up asking our AI overlords for a good definition. And here's what it said. For Gimbal Lock, this occurs when using Euler angles, that's the XYZ rotations that we see in the inspector. When one axis reaches plus or negative 90 degrees, you lose a degree of freedom and rotation can become unpredictable or take an unexpected path. For Quaternion flipping or Quaternion ambiguity, Quaternions can represent the same rotation in two ways. Q and negative Q both represent the same rotation. When Unity interpolates between two rotations, it might choose the wrong Quaternion representation, causing the rotation to take the long way round. In other words, greater than 180 degrees instead of the short path. And I'll provide these definitions in the description below. I've ran into a similar problem before when trying to create a first-person controller and having limits on the up and down or X rotation of the camera. Now, for the most part, these principles apply to when using code to rotate objects, but it's interesting to see that they affect animation as well. At this point, let me show you what I decided to use to create my animated roll mechanic. All right, so here I have my D6 dice, and the first thing that I did was create a roll animation. This is just an animation of the dice spinning in a loop. And one thing that I'll do is I'll probably create a couple different spin animations and create a blend tree. That way I can periodically change the way that the dice is spinning while rolling. I then needed to create animations for each possible roll. And at first, and part of the issue was that for each of these animations, I had just one single frame of the dice rotated so that the face was pointed towards the camera. Once I had created all of these animations, I put them into a blend tree. This will allow me to set a parameter which will in turn choose which face of the dice will point towards the camera. Once I created this blend tree, I then just needed to create the transitions between the rolling state of the dice actually spinning and the state of the dice after it's been rolled. For this, I needed two parameters. Both are triggers. The first is called roll, and the second is called reset. From the transition from rolling to rolled, I disabled has exit time. I set the transition duration to 0.1, and the condition is the roll trigger. For the transition from rolled back to rolling, has exit time is false. The transition duration is 0.25, and the condition is reset. So at this point, let's play through the project and you can see how it's working. So currently our dice is being animated in the rolling state. It's just playing its spin animation. And for the D6, I actually have 3 different spin animations already set up. And I can use this rolling parameter to change which spin animation is being used. Now you can see that if I click the roll trigger, the dice will then stop spinning and one will face towards the camera. If I then change the state parameter to 0.2, it'll then roll a 2. 0.4 will roll a 3, 0.6 will roll a 4, and so on. Now there were 2 main things that were contributing to the issue of having a snappy animation. The first I've already mentioned, and that is with each roll animation, where the dice stops rolling and each face points towards the camera, I had this animation as only 1 frame. I extended this animation to be 15 frames, And I made it so that the dice rotates down so that by the end of the animation, the face that I want pointed towards the camera is in position. The second problem that was contributing to the bad animations was the transition between rolling and rolled. At first, I was thinking it might be nice to have a longer transition so that the dice smoothly rotates to face the camera. But having a longer animation in this instance gave the dice more time for its rotation to get messed up with those principles we talked about. So at first I had the transition duration set to 1 second. I even tried 2 and 3 seconds. But to fix the problem, I set the transition duration to 0.1. This does a couple of things. First, it extends the steps it takes for the dice to rotate to its final position, meaning that with a shorter transition, the dice has to rotate faster or farther for each frame in order to get to its final position. Secondly, it gives the dice and the animation less time to get messed up, like I've said already. And thirdly, it makes the animation faster, and when things move faster, it's harder to notice any problems or any imperfections. And so even if it's possible that the issue is still happening, it's a lot less noticeable. And this is actually a common solution in game development. How often do we fake something in order for it to look good, but behind the scenes, it's actually not as complicated as it looks? To fix the issue, I also tried changing the interpolation settings for all the different animations. My favorite is when you set the rolling or spinning animation to Quaternion. I then just have the dice oscillating back and forth. Now there probably is a better solution to actually getting the dice to rotate without snapping to its position with a slower animation or transition. But for this simple project, I think it looks just fine. Now once I had a good solution for one dice, then came the tedious part, where I had to go through each dice, create a roll or a spinning animation for that dice, and then I had to create an animation for each face of the dice. Once I got up to the D20, it took a good amount of time, but luckily I was able to get into the swing of things, and there were a couple techniques that sped up the process, namely using the record button in the animation window instead of having to add the properties individually. Alright, now that's everything I'm going to cover in this video. For the next step of this project, I'll probably be working on the code behind the animated roll mechanic. Now, if you like this video, make sure you give it a thumbs up. If you have any questions or suggestions, leave them in the comments down below. And make sure you subscribe to my channel so you can be up to date with all my latest videos. Thanks for watching, and we'll see you next time.